Alright, folks. I think I kind of get the idea how I can not have loud voices recorded for my lecture videos. So I'm gonna have a little distance between my mic and the screen. Sorry, I realized that the previous video is really loud. So let's start with the one dimension. I'm gonna put the title here just in case some people forget. 1D conservation of momentum. Let's get this started. Well, there are technically two formulas that you can approach. What you're seeing here is a simplified version for people who like to use sigma to indicate sum. That's okay too. And when it comes to no hyphen having variable is what I like to say initial, final. So it is basically depends on your preferences. You can actually write down in this way. Just in order to show that my initial momentum, sum of it. So when I say sum, it's SUM, everything. When I think about initial and final situational momentum, especially collision, whatever happened as initially should be conserved to the final momentum. If you have more than one system, like the one that you see below, like object 1, object 2 collide, something like that, either going left or right situation or colliding up to down situation, regardless of whatever scenario it will be, you're gonna have them equal together. Again, initial left side equal to final right side. If it's something related to explosion situation, like what I mentioned about grenade, I like to put that whatever change of momentum happen in one of the system or another system, it can be system number 3 and move on and on and on, regardless of how many inside of the scenario of the question. Anything that happened in object number 1 and 2 in a system, they should make net zero because it was originally starting as a net zero. This is explosion situation, which is equal but opposite impulse can happen. And because of opposite impulse, if you think of, it's actually change of momentum, which can be decided by force times by delta t, which is change of time, Now that's why if momentum cancel out as 0, then you're gonna see force as 0 too. So that's why you don't have any of the force occurring in here. This opposite concept, what I mean by that is if one object go left side, right side, those kind of grenade explosion situation, if you have that, think about that as Newton's third law, which is action and reaction. If I apply 15 Newton of punching force to the wall is actually giving me 15 Newton of that reaction force to my fist. So think about that way. Now, let's get our classic example started. Well, as you may see, I have two objects. Let's call green one as 1 and red one as 2. So in this system, initially, I have traveling ball number 1 and ball number 2. This is very identical as our demonstration of FET simulation of collision lab. So my first step, generally what I like to say, is set up equation using formulas. But what formulas? Well, and how many equations? I like to set up for initial and final. So if this entire system is going in or going on inside of the isolated system, what I can tell you is P1 My bad. Oops. There you go. Pi should be equal to Pf. My initial momentum should be equal to my final momentum. Now, what happened in here is we do not know our one of the initial velocity, which is carried by our moving object number 2. And we're gonna list generally any of the clue that is given. Let's list on the right side. I have M1, which is 0.500 kilogram. Always don't forget that. When it comes to physics 20 and physics 30, you have to convert gram into kilogram. Kilogram is our basic unit. And when it comes to velocity, we need to decide which way is positive, which way is negative. Probably let's decide right as positive, left as negative in this situation and see how it goes. Anything that go towards right side or east side, I'm gonna put it as positive. M2, I do not, oh, never mind, I do know. Mass 2 is 0.800 kilogram. And my V2 is, I don't know. Now we have another clue. You can use hyphen or you can use final with the little subscript F. That's your choice. Again, make sure you're identifying your good directionality. So I list every single clue. Now let's proceed to a second step. Second step. Generally, I copy formulas and put it inside of the equation that I set up accordingly. What I mean by that is, in initial situation, which is what's going on in here, that's initial. What's going on the right side, that's final. So technically I have mass 1 momentum, mass 2 momentum. And these two equals to mass 1 final velocity having momentum, mass 2 its final velocity having momentum. Now, it looks nasty, but in fact, it's actually not a complex formulas. It's just mass time velocity. We basically need to isolate for this V2, which means I need to move my unwanted formula to the other side by subtracting it in this case. So what's going to happen is M2 V2 is basically equal to M1 V1 final plus M2 V2 final minus M1 V1 final is equal to my M2 V2. Now we don't want mass in here anyway, because we're interested in to find velocity of the second object. I'm just gonna divide everything into M2. And on the left side, since you have a repeating variable and cross multiplication situation or repeating variable on upside downside, whatever you want to call, they're gonna cancel each other. So that's my second step. Now my third step, which is our one of the last one, third step is basically substitution. What stuff we can substitute? Well, we are substituting what we listed on the upside, and we're literally putting that inside of our expression. So that means my V2 is equal to 0.500 kilogram times by V1, which is final negative 17 meter per second, plus my second mass, which is 0.800 kilogram, times by my final velocity v2. Oops, I forgot to put, there you go, positive 9.0 meter per second, everything close, minus, it is very long numerator, mass 1 again, which was 0.5 kilogram. So it's gonna write down like this. And my first speed, 30 meter per second. Technically it was positive. Now generally what I do before I put it inside of the calculator, even as an expression, I put double bracket just because in order to make me realize that this is an entire numerator. Denominator is a second mass, which was 0.800 kilogram. Now let's put this inside of the calculator. Then let's see what happened. And this is a part where some people like to do little by little and then save that answer from a calculator and then use further. You can use that way. In my case, I like to do it everything at the same time. It's your choice. Now, if you punch every number inside, you actually have, fortunately it's not a nasty number, you will have negative 20.375 meter per second. At this point now you need to do significant digit. In this case the significant digit, I believe it was 3. No, 2. I lied to you. 2 significant digit, which is technically expressed as negative 20 meter per second. Now negative notion was our own example of showing it, which was left direction if I recall. So we need to put that vector format into quantity followed by direction. This was our example number 1 related to collision situation.